So let's look at number 3. Is e to the 3x minus y to the 7th equals ln x. And the directions were just find the derivative. So we're going to just find dy dx. And I'm sorry, I know a couple of you responded to me in the chat. I'll get back to you as soon as I'm done recording this video. Okay, since I hit record, I don't want to pause. I'm not ignoring you though at all. Okay. So just find dy dx. So for the first term, exponential derivative is itself, so it'll just be e to the 3x. And then we're going to chain on the derivative of 3x, which is a 3. So it'll be 3e to the 3x. Minus, and then derivative of y to the 7th. That'll be 7y to the 6th dy dx. And then derivative of ln of x is 1 over x. And so after that, it's just a bunch of messy algebra. You just want to get dy dx by itself. So I'm going to subtract this over to the other side. And then the last step would be to divide by the negative 7y to the 6th. And you are going to end up with a fraction within a fraction, which is totally fine. I mean, again, if your answer looks like a gigantic mess, then you probably did it right. You are not allowed to just bring this x down to the denominator. If it was just this, you would be able to do that. But as it stands with that extra term in there, you're not able to do that. Now, if it's really bothering you a whole lot that there's a fraction in a fraction, you can multiply all 3 terms by x to cancel it out, and that would be okay, but you can't just slide this x down to the denominator. But if you want to multiply them all by x, you will get 1 minus 3x e to the 3x over negative 7x y to the 6th. So if you multiply all of them, then it would be okay. But there's absolutely nothing wrong with stopping here. So that's my suggestion. I would just, leave it alone. And then we're going to look at the bonus question. So it says y equals 4x minus 9 is tangent to this function. And our goal is to find k. K is going to just be some number. So k is just going to be a value. So that's what we're trying to find. So since they gave us a tangent line, let's start with that and what we know about tangent lines. What is the slope of this line, guys? Just by typing in the chat, slope of this line. Memories from algebra class. What is our slope of this line? Good, that'll be 4. Do you remember good old y equals mx plus b back in algebra 1? That was like, 3 solid months of your life, just y equals mx plus b. All right, so the slope of the tangent line is 4. So that's our slope. And so we're going to set the derivative equal to 4. The derivative gives you slope of the tangent line. So our derivative is going to be equal to 4. So the derivative of this would be 2x. I had a lot of people write 2x minus k. K is just a number, so that derivative would be 0. K is going to just, go away. So that's our derivative. We're going to set that equal to 4. And so x is 2. And I know you're probably like, Ms. Cole, we're trying to find k. I don't really care what 2 is, or what x is, that x is 2. But we have to get x and y before we can get k. So I'm going to plug 2 back in for x here, and we'll solve for y. So if this is 2, we'll have 4 times 2 is 8, minus 9 is negative 1. And then I'm going to plug into this function to get k. So the f of x, that's y, the output. I'm going to put negative 1 in for that. And then 2 in for x. So 2 squared would be 4. Then minus k. And then I'm going to just solve for k. So I'll subtract over the 4. And then the negatives are going to cancel. So this would be your final answer. And I just want to show you this on the calculator as well so that you can see a visual of this. I'm going to put in this function, which we found k was 5. So this will be x squared minus 5. So a parabola moved down 5. And then I'm going to put in the tangent line. So 4x minus 9. So we're going to get a parabola and then the line tangent. And so there's the parabola, move down 5, and then there is the tangent line. And it's tangent at the point 2, -1, which is like right about there. So it just comes by and like kisses the graph at that 1 point. So that was the bonus. All right, I had somebody type in number 5, so I'm going to do that next. And if you want to be thinking about, I'll do 3 more. So I'll do 5 and then I'll do 2 more. So think about what else you might want to ask about and type that in the chat. All right, so this says, here's our equation. And it says, write the tangent line equation at y equals 2. So if we're going to write an equation, we need a point and a slope. And so for this one, I gave you y is 2. So I gave you y instead of x. It really doesn't matter. As long as you have one, you can plug in and get the other. So y is 2. And I'm going to plug 2 in for all of the y's, and I'll solve for x. That'll give me my x value. All right, so 2 cubed is 8. 2 squared is 4, so this will be 4x plus 3x equals 15. And so this will be 8 plus 7x equals 15. And I'm going to subtract over the 8. That'll give me 7. And so x is 1. So that is the point. We just plugged in and solved. Slope comes from the derivative. So we're going to have to do the derivative of this. So for y cubed, that is 3y squared dy dx. Plus, and then this is going to be a product rule. X is the first function, y squared is the second function. So product rule is the first times derivative of the second. That'll be 2y dy dx plus the second times derivative of the first. And derivative of just x would just be 1. So that was a product rule. And then derivative of 3x will be 3. And derivative of 15 is 0. So we are going to plug in 1 for x and 2 for y and see what we get. All right, so y is 2. 2 squared is 4 times 3 is 12. And then here, this would be 1 times 2 times 2. So that would be 4 dy dx. Again, y is 2. So 2 squared is 4, and then plus 3 equals 0. So combining like terms, this will be 16 dy dx plus 7 equals 0. And so we're going to subtract the 7 and then divide by 16. And so that is our slope. So this is our point, this is our slope, and we're just going to put it together into the equation. So y minus 2 equals -7/16 x minus 1. All right, and then I had someone type in 7 and then 8. So I will do 7 and 8 for the last two. All right, 7 is the ladder problem. So we have a 20-foot ladder sliding down the wall. So the ladder is 20 feet. That is not changing, that's constant. But since it is sliding, I need variables for the other two sides. And so it says the ladder is sliding down the wall at 0.25 feet per second. So that's the rate for the ladder sliding down. So dy dt is negative 0.25 feet per second. It's negative because the top is sliding down, so that distance is decreasing. And we're asked to find the rate of change of the bottom moving away from the wall. So we're looking for dx dt. And that will be positive because the bottom is moving away from the wall, so that distance is increasing. And then we're going to pause at the moment when the foot of the ladder is 12 feet away. So that's when x is 12 feet. So the relationship between the variables is going to be Pythagorean theorem. So x squared plus y squared equals 20 squared, which is 400. And then the derivative is 2x dx dt plus 2y dy dt equals 0. Again, the latter is not changing length, so that's going to be a 0 rate of change. And you can go through and divide everything by 2. 0 divided by 2 is still going to be 0, so it's just convenient to cancel the 2's out. And then we can plug everything in. So x is 12, and dx dt is what we're trying to find. Y we don't have, so we'll come back to that. And dy dt is negative 0.25. So if you're missing something, you're going to go back to this original relationship and plug in what you have. So I'm going to plug in 12 for x. 12 squared would be 144 plus y squared equals 400. And we're going to subtract that over, you get 256. And when you square root that, you get 16. But if you didn't know that, you could just leave it as square root of 256. There's absolutely nothing wrong with that. Or if it came out to something that wasn't a perfect square, you would just leave it as square root of whatever. All right, and then what we need to do is get dx dt alone. Be careful, this term is negative. Let me erase this negative here and just put it out front. This term is negative because that was a negative rate for the 0.25. So when I move that to the other side, I'm adding it over. So it's going to be positive when I move it to the other side. So that will be positive, and then we're going to divide by 12. Now you can leave it like that. You could have even left it with the square root of 256. I'm going to go ahead and simplify this because a lot of people did, and if you're following along, I want you to be able to check with what you have. 0.25 is a fourth, and a fourth of 16 is 4. So that would be 4/12, which is 1/3 feet per second. But once again, you didn't have to do that. You could have left it like this, and that's perfectly fine. Especially if this didn't come out to a nice number. If you had left it as a square root, just hands off. All right, and then the last one I'll do is number 8. So this was the baseball problem. So we've got our baseball diamond. And each of the sides is 90 feet, and that's constant. That's not changing because the bases themselves aren't moving. And so we've got a guy running from second to third. So here's second, here's third. He's somewhere in between, running this way. My picture is not to scale. I just put him somewhere in the middle. And we're going to be looking for his rate of the distance between him and home plate. So I'm going to connect him to home plate. So this is the triangle that we're focusing on here. So this distance between third base and home plate, that's 90 feet. That's not going to change. But we need variables for the other two sides. And so let me read through and get the information from the problem here. It says he is running at 16 feet per second. So that's going to be our dx dt. That's his rate of change. It will be negative 16 feet per second. Because as he's running to third base, this x distance is decreasing. It's getting shorter and shorter as he's going there. So that will be a negative rate. And we're being asked to find his rate of change, the rate of change of the distance between the guy and home plate. So dy dt is what we're looking for, and it should be negative. I realize he's not running directly towards home. You can't skip third, that's cheating. He's running this way, but as he does that, he's still getting closer to home. And then it says we're going to pause at the moment when he is 19 feet from third base. So that's when this x distance is 19. I know when we went over one on the study guide, I gave you like the other distance and you had to subtract from 90. I didn't do that here. I just gave you the x distance, so 19 feet. So again, it's going to be Pythagorean theorem. We'll have x squared plus 90 squared, which is 8100, equals y squared. And then the derivative will be 2x dx dt. This is a constant, so it's gone, equals 2y dy dt. And again, I'm gonna cancel out the 2's. So x is 19, dx dt is negative 16, y I'm missing, so we'll come back to that, and dy dt is what we want to find. So since we're missing that, we're going to go back to the original relationship and plug in 19 for x. I don't actually know 19 squared off the top of my head. 19 squared, 361 plus 8100 equals y squared. So that is going to be 8461, which is not a perfect square. So I'm just going to leave it as this square root. And so last step, you're just going to divide that to the other side. And units are feet per second.